Let's start by creating the interlocked example. We are going to create the run method. We are going to add an integer for the iterations per thread. That is going to be 1 million. We are going to create a shared resource called counter that is going to be initialized with the number 0. Now let's write to the console that we are starting the interlocked example. Now we are going to use the parallel for loop at the using. We are going to start from 0 and create a task for every processor. Increment. Here we need to add an action. Inside the action we are going to have a for loop with an integer equal to 0 while it's less than iterations per thread, and we're going to increment the for counter. Then we're going to create a method called increment, and here what we're going to do is basically increment the counter. We are going to mimic the, actually we can simply copy paste it, our log method that will write to the console a message and the thread name. Now let's write to the console message stating final count is equal to the counter and let's read the console buffer so we can wait before it ends. And let's see how it behaves. Okay, so basically we created 4 tasks that should be incrementing the counter by 1 million each. But here we see that instead of having 4 millions, we lost more than 700,000 values. What we are observing here is the shared resource is being taken by several tasks, and in the middle they are racing to write this value, which leads to a data corruption issue. So now let's calculate how much information are we missing. Let's say we lost X values and missed. So let's run it one more time. And here you can see how many values we are missing. This time was far more. Okay. Now to understand a little bit what is going on, let's create a log. Now we can see how it behaves. Here you see that if we log, all the values get there. So we're not losing anything because there's no race condition. Now I'm going to show you how to implement this with the interlocked class. So we're going to remove the log and implement the same operation with the interlocked class, which will guarantee that the increment operation is going to be processed by the processor in one single operation. As you can see, we didn't lose any value. Now let's try to do some benchmarking so you can see how interlock performs against regular lock or monitor. Okay, so here we see that it is taking this amount of milliseconds, so we're going to just make a note with interlocked. Now let's monitor how it behaves with the lock. Now let's run it. As you can see, it takes around 3 times more with the lock object. This is because the lock contention we observe here. So basically what we have seen during this example is the difference between the regular monitor lock and the interlock class. Interlock provides non-blocking mechanism for synchronizing the shared resources among several threads.